Hello everyone. The last week I shared a blog post about how to make more rich UI interfaces for AI. Most of the AI nowadays uses chat, and in the article I argued that we can get much better experiences if we add more rich elements like images, buttons, or clicks. In the article, which you can read in Medium, I introduce many examples. All of these examples use HTML and FastHTML because this framework is in Python and everything happens in the backend. Then we can render, the LLM can render these Python elements to be returned to the UI. However, this is done by a not so obvious mechanism called out-of-band swaps. And one user, Shwain, asked if I could do a more detailed video about this. So this is what we are going to see today. When to use out-of-band swaps in HTMX and FastHTML, and when not to use them. So let's get started. The demo that we are going to have a look is the one about HAL 9000. This demo, which you can definitely access here, has an interface with many different parts updating. This is a simple game where you can talk to HAL from Space Odyssey, and depending on your actions, for example, if I want to explore the central corridor, then the LLM or HAL will generate new options, new text conversations, but at the same time, it will also generate an updated image for his mood and some short description of what is his current mood. If his mood gets very bad, you know what happens. HAL deactivates you. So let's see how we achieve this. Here, as I said, there's many different elements to be updated. In the code, which I explained more in detail in the article, we use only a single endpoint, send. This endpoint receives both the clicks of the buttons or your input text. And this is the typical endpoint where you would have an LLM listening. But here it listens to everything happening in the front end. In order to update these elements, we just process the data we receive, whether it's a message or a button click. Then we call the LLM using Claudette. And the interesting bit is here. Here we are just returning the user reply. So we see what we reply to HAL in the UI. The message from HAL, the environment message, which would be this update or what's happening, the color component, which will be his image, and the input area, which is just to clear it. All of these elements are just returned in a list, but if you check at the response from one of these, let's make another request. We will see here in the response, we'll see the reply container, see? This is the first one, the user reply, then the HAL message, and so on and so forth. This is the color card, which is a complicated SVG. And finally, we clear also the text area. Most of these elements, of course, are not together in the UI. This element is not together with the input. So the way to do this is these out-of-band swaps. What out-of-band swaps do is HTMX allows you to tag some elements with this. Let's see, for example, the input area. And what it does, it says, whenever you make a request and you return an element with this tag, I will replace this element for the element with the same ID. So essentially what happens is like we are returning an empty input area, and HTMX is like, okay, there's already an element with this ID in the front end, so I will just swap it. And the same happens here, see, for the color card. In the case of the messages, it does not use out-of-band because we just say append this message to the message list, and that works okay. This is a very powerful way of updating the UI because I can just create my elements like the color card and set this out-of-band. Let's see what it is. Yeah, and set this out-of-band swap. Then every time I return this element in any endpoint, it will be swapped correctly to the place where it belongs. So I don't need to worry about the structure. So should you use always out-of-band swaps? No. And now let's see the second part, when not to use an out-of-band swap. For this example, we are actually going to see a different app. This is an app to track your habits. You can create different habits with units, and essentially you can click to add more habits of this day. You can also remove the latest track, and you can remove the habit itself. What you saw now is that the heat map here, which says indicates how many habits you have performed every day in vertical, needs to be updated whenever we click on some new tracking. For example, you see here that when I click simple and sinister, this gets darker. It's hard to appreciate that. See, 13. Now, my initial way was to use out-of-band swap here too. So how would this work? Whenever I track a habit, this is clicking +1. What I do is I record it in the database, and then I return the card, but also I regenerate the heat map. If you see this in the DevTool, in the Network tab, you will see whenever I click +1, I'm calling track habit, but actually we are returning also an image together with it, which is the heat map. This is not ideal because generating the heat map is slow. We could try to optimize this, but instead we will use a different method. Here we see that the request took 400 milliseconds, and this is quite a lot. Half a second is already noticeable, especially when I do searcher squads. I do 5 or 10 at a time, so when I click, you see it's not very responsive. There is a noticeable lag. So how do we solve this? In order to solve this, we will use a different HTMX feature. We will use an HX trigger. So what we will do instead is I do not want to update the heat map on every request because every time I click +1, then if I have to wait for the heat map to be generated, it's going to be much slower. Instead, what I would like is just track this result and reactively update the heat map. We can accomplish this in a very, very easy way. The only difference that we will need to do is this out of swap needs to stay still because I remove it from this, we just move it from here, so do not pay attention to that. And I will just fix the +1, not the -1. When I click -1, it will still send back the heat map. So I do not want to remove the out of band. But in the new method, the out of band is not required. Instead, what we will do is we will leverage HTMX and say, whenever this event happens, when an HTMX event happens and you swap some content in, that would be our track request, when it comes from the habits grid, and this grid is this grid here, right? You see here, habits grid. So what you're saying here is whenever there is a swap coming from the habits grid, trigger this HX request, which is get the heat map, and do this with a delay of 500 milliseconds. So that way, every time I click, the heat map component will be listening in the front end, and it will say oh, there is a new event from the habits grid, and I will update myself the heat map. But because there can be many updates at the same time, I will just trigger this after 500 milliseconds. And if more events keep arriving, I will hold off 500 milliseconds. In order to make this work, the second thing that we need is to actually add an endpoint to get the heat map. Up until now, we always return the heat map as part of another endpoint, but now the heat map itself needs to be able to call the heat map endpoint to update itself, no longer out of band. What we see when we do this is that in this version, which is using the new method, if we click the searcher squads, it's much snappier. Not sure if you can see in the video, but if you go to the network tab, you will see that first of all, track habit takes half the time. So quite good. And the second is if I click here many times, you see, there is only one heat map update. It's not called every time because of this delay. The next step for this would be to do the same for the -1 and the delete. In this way, the UI will feel snappier because you will not make the update of the habit card wait for the rendering of the heat map. Why this is not a problem in this example? This is not a problem because the bottleneck of this application is the LLM generating the response. It doesn't matter if returning everything makes it slower because the slowest part, the bottleneck, will be always the AI. And it's so slow that all the rest of considerations do not matter. In the case of Compound, the slowest part is the heat map. And updating the heat map is different from clicking one of these buttons. So when I click here, right into the database, which is very fast because it uses SQLite, because this is a FastHTML application. So SQLite is extremely fast. So I do not want to hold off updating the UI because I have to render the heat map. Instead, I just write this to SQLite, I return the element, and then the heat map can update itself later.